All right, so for this first one, we're writing an equation through a point, and we're given the slope. Well, I hope that you are immediately then thinking about point-slope form. And so if we went to write this equation then in point-slope form, it would be y minus the y-coordinate. My y-coordinate here is -2, so minus the -2 becomes a +2. And that's going to equal my slope, parentheses, x minus the x-coordinate. The x-coordinate here is a -4, so minus the -4 becomes +4. And so there's our equation in point-slope form, which is great, except that we're told that we actually want it in slope-intercept form. Well, the nice thing about point-slope form is that you can use it to get into slope-intercept form. Basically, what we need to do is just solve this equation for y and get rid of the parentheses. And getting rid of the parentheses is the first thing I'm going to do. So I'm going to go ahead and call this y plus 2 equals, and then 5x plus 20. All right, from there, we just have one last step, and that's to subtract the 2 from both sides. When we do that, we end up with our slope-intercept form, and it's going to be 5x plus 18. And that's what we're looking for here. So notice point-slope form is very useful for being able to take us into that slope-intercept. It allows us to find that much easier than some other methods might allow us to do. The second problem is asking us to do the same kind of a thing, of putting it into slope-intercept form, but obviously the starting equation looks a little bit different, right? This particular form of the equation is called standard form of a linear equation. And we're actually going to be working with that as kind of our big focus of today. And the first thing that we should be able to do with it is write it in slope-intercept form. All right, so if I want to turn this into slope-intercept form, again, I want to be able to get it into y equals. Well, remember the work we did in our last class where we were solving those equations, solving the literal equations, kind of getting us ready for this. And the first thing we want to do, as we may recall from that, is we want to get rid of the addition subtraction, which in this case means getting rid of the 3x. So I'm going to want to subtract 3x from both sides. Now on the left side then, that just leaves me with my 2y, which is good. We're closer to what we want because we want it to just be y equals. On the right side, you actually have a choice here on the right side. You could either write this as 18 minus 3x, or you can write it as -3x plus 18. Notice those two statements are exactly the same. Which one am I going to use? Well, slope-intercept form, like this up here, we tend to write the slope and then the intercept. So I'm going to write it in that order. I'm going to use the one where I write the x first. Even though it's negative, I'm going to go ahead and choose to do that. It's not like it's wrong if you do it the other way, but this is more typical of our slope-intercept form. All right, from here we do have one last step. To get the y by itself, I now need to divide both sides by the 2. And when we divide both sides by 2, well, the good news is we have just plain old y equals on the left side. But on the right side, we need to see how this is going to look. You might think about, okay, well, I'm going to go ahead and then write that as -3x plus 18 all over 2, because that's kind of what a lot of them worked out to look like yesterday when we were solving especially the literal equations. But that doesn't exactly look like slope-intercept form, does it? And so instead what we can do is we can actually divide each of those terms individually by 2. And so I could instead write it as the -3x being over 2 plus the 18 being over 2. Which still doesn't quite look right, but we can make that look right. Because like this -3x over 2, I want to turn that into just something times x. What is actually being multiplied by x here? It's going to be negative, because you see that's a negative out front there, but then it's 3 over 2, right? What's 3 over 2? Well, we can just call that 3 over 2. I'm going to call that -3/2 x. That's the exact same thing. Notice if I multiplied that x into the fraction, it would end up in the top. It'd be -3x all over 2. And then plus is still the plus, and then 18 over 2, that's the easy part. It's plus 9, right? And so that's how I'm going to write my answer. I'm going to write it as -3/2 x plus 9. Then that is our slope-intercept form that we were out to find in the first place. And so we're done. Now we did introduce standard form here. I want us to add standard into our notes. You may recall a day or two ago, you took notes here on slope-intercept form and point-slope form. Ideally, you'd have a little bit of room below those, and you'd be able to just add standard form right below that. So go ahead and please add standard form also into your notes. You've now got this new standard form into your notes. Now, if you look at the ones that we took down before, the slope-intercept form and the point-slope form, those two equations both had like, well, you know, this is this and this quantity is this. You know, this part of the graph could be represented by this part of our equation. And we had the same thing coming up in the other equation as well. But you notice there's no such correlations made with standard form. So then, what do A, B, and C actually mean if I look at the graph of this equation? Nothing by themselves. Standard form is called standard form because when we go to write equations ourselves, this is a very typical way that equations end up looking. Because more often than you might have experienced so far in your mathematical career, rather than one variable depending on what happens with the other one, they both tend to have an interplay together. And so when we think about it, we tend to put them on the same side rather than different sides. And so standard form often comes up just with how we write them ourselves. So then it's really a matter of saying, well, if this is the way equations pop up, how do we deal with it? And you're going to see that while A, B, and C may not represent something specific on the graph all by themselves, they actually are very useful for finding all sorts of things about the graph. And that's what we're going to be doing as we go forward. We have been graphing a lot recently, and so we will continue that theme as well. We're going to be graphing equations from standard form today. 3 of them specifically, starting with this one. So go ahead and write this equation above your first graphing grid, and then also after you've written it down, think about how would you go about graphing it. All right, so as you're thinking about how you would now go about graphing this, my guess is that you're probably all thinking about the same way, because most of us tend to go the same direction here, which is it doesn't look like something like what I know how to work with yet, so I'm going to turn it into something that I do know how to work with, which would mean subtracting 2x from both sides, because if I do that, then I can turn it into y equals. If I do that, I end up with y equals a negative 2x plus 12. Is that then graphable? Yeah, we can graph that. I mean, that's our typical way of being able to graph from an equation like that. So the first thing we do is we got to put a point up at 12. Although, do you have 12 on your particular graphing grid? Maybe yes, maybe no. Most of the time it's no. Yeah. And so what if yours doesn't include the 12? Now mine does include 12, so I just am kind of showing where it would be. If yours didn't, you're kind of visualizing this at the moment. Where do we go from that first point? Where do we go from the 12? Yeah, it's going to be down 2 and over 1. And so even if that doesn't fit on my grid, I can start visualizing that. Okay, I'm up at 12. If I go down 2 and over 1, where would I end up? Well, I'd end up there. I'd end up 10 and over 1. So even if yours doesn't include the 12, you can actually start making this just by thinking a little bit out of the box there. For something really close to our graphing grid, that's pretty doable, and that's pretty reasonable. Now, if this was actually like negative 2x plus 35, that might not be as feasible a strategy, right? But it's at least going to work for us here. All right, and then we're going to be drawing in our line. So we're just going to keep on doing the down 2 over 1, down 2 over 1. And remember, we just put in lots of points, mostly because that's just going to help us to be accurate with actually drawing in the line that goes through them all. Because I'm going to want to plot them all and then grab a straight edge and draw the line. So, do so. Plot those points, draw the line that goes through it, please. So having done that one, we now move on to the next. And we're going to be graphing this one. So again, write down this equation above your next graphing grid, and then again think about how will you make this graph? And actually start working it through, because I want you to see what happens with this one personally. So I'm guessing that we started by going ahead and solving this one for y equals as well. The thing is that when we do so, we end up with something that looks like this. Now I went ahead and wrote them as decimals, not fractions. The fractions would also work, like negative 2/5 x. That's fine, that's good. Why did I write as decimals? Because sometimes the fractions are a pain to try to type into this thing. Yeah, that's about as deep as it goes. All right, but looking at this, how are you going to graph that? This thing is going to be a pain to deal with, right? This is going to be troublesome, and oftentimes that's the case. When we've been graphing from slope-intercept form, oftentimes we're working with nice, pretty numbers. You know, we started a whole number. And then when we started a whole number, it's a lot easier to use our slope and know how far we're going up and how far we're going over by, again, whole numbers. This is not. So this one turns out to be really messy to try to graph by turning it into slope-intercept form. Although possible, it's very likely that we're going to end up making mistakes because of the weird numbers. So instead, we're going to see another way to be able to graph this. And this is actually going to be our main technique that we use whenever we see an equation in standard form like this. And that technique is actually going to be to find our x and y intercepts. Basically, we're going to be filling in these two blanks up here. And when we see how to find those, we'll then be able to make our graph. So let's see how we would do this first one. So I'm just going to do this one first here. So blank, comma, 0. What is 0 in this point? Is that the x or is that the y? The y. And so what that tells me is that I'm going to take that 0 and I'm going to plug it in for y in the equation up here. So I'm going to do 2x plus 5 times 0 equals 12. Now you notice the nice thing about plugging 0 in is it makes the math really fast and easy from here. Because 5 times 0, of course, is going to be 0. So really, it just boils down to 2x equals 12. And if 2x equals 12, then we know that x is going to equal 6. So that's what this first blank is. It tells me that that first point there is going to be at 6, 0. Now, 6, 0, which axis is the point 6, 0 on? Is that on my x-axis or is that on my y-axis? It is on the x-axis. Because I'm going to be sitting over here at 6, 0. So because I know the x is a number other than 0, but y is a 0, that is my x-intercept. So we started by finding the x-intercept. The next point, notice I'm going to be plugging 0 in for x. That means that's going to be on the y-axis. This is going to be finding the y-intercept. And I do so by taking that 0 and plugging it in for x here. So we're going to do 2 times 0 plus 5y equals 12. And we're going to solve this through. Now again, the 2 times 0, that should be easy. That's just going to be 0. So really I'm just solving 5y equals 12. It won't take you too long, and you're going to basically be going straight through these, and you probably won't even have to write out the algebra work. You're just going to go straight to an answer, because these do get pretty quick. So I'm going to end up with doing 12 divided by 5. Yes, that is a decimal. That gives me that 2.4 that I saw crop up earlier. So it's going to be at 0, 2.4. But now I can actually look at plotting that point. If I plot the point at 0, 2.4, yes, I'm having to be just as precise as I can in locating 2.4. But notice what I now have on my graph. I have 2 points. How many points do I need to be able to draw on a line? 2. And so you grab your straight edge and you draw the line that just goes through those 2 points. Notice there's no more, like when we deal with slopes, it's not like I'm going to try to keep that pattern going over and over again. I only have those 2 points to work with. So you plot those 2, grab the straight edge, and draw it through. And having done that, we've now done our first problem where we're graphing from standard form. And you'll notice that kind of the critical piece of graphing from standard form was really just figuring out what these 2 points were, the x-intercept and the y-intercept. And again, remember how we can tell which one's which. The x-intercept has a non-zero x-coordinate. The y-intercept has a non-zero y-coordinate. That's going to be useful to remember, because what I want you to do now is just focus on finding those x-intercepts and y-intercepts. I want to practice getting this idea really down from standard form. So please write down the equations and find the x-intercepts and y-intercepts for each of them. So for that first one, I'm going to find the x-intercept. The x-intercept means I'm plugging 0 in for y. So I go over here, and I'm going to do 4. Oops, not 0 for x. So it's going to be 4x plus 6 times 0 equals 12. Of course, that just means I'm going to be doing 4x equals 12. Therefore, x is going to be 3. So my x-intercept is going to be at 3, 0. All right, and then I head on to my y-intercept, which means I'm going to be plugging 0 in for x. So we do 4 times 0 plus 6y equals 12. Of course, that just means I'm going to be doing 6y equals 12, so then y must equal 2. That gives me then the point 0, 2. The one big danger that you will run into as you get going with these, especially as you really get rolling with them, is that you're going to do all this work over here, and then after having done all that, you're going to say, okay, so I know this graph goes through 3, 2, because I just found an x of 3 and a y of 2, and you're going to think of it as one point if you aren't really careful about reminding yourself that it's actually 2 points right now. Because remember, in order to get the 3, I plug 0 in for y. That's the coordinate pair. So just be cautious that you don't fall into the trap of thinking that that is a single point. Gotta remember it's 2 separate points. Okay, let's check in on that second one. You can see here the answers we would have ended up with and the work. Now notice in the work, all of a sudden my work looks a little bit shorter. Well, I already know that once I plug 0 in for something, it's just going to go away, and because that whole term is going to become 0. So really I could start shortcutting things a little bit and just leave out that 0 from the start and just go to the 10x equals 16 and the negative 4y equals 16 to be able to find my values. And so you notice this starts getting a little bit expedited as we start going through them. And then our last one, you can check those answers there. And what you'll probably notice is that as I was doing that third one, a lot of you were waiting on me to finally get that thing written down, right? Because he started going faster. And that really is going to be the thing about this is, yes, standard form, basically when you're given an equation in standard form, you're always going to have to do a little bit of work in order to be able to graph it. You can't just look at it and know. But hopefully what you're starting to see is that it really is a little bit of work. There's not a ton of work and not a ton of algebra that you're having to do in order to be able to come up with where those 2 points are. And we're now going to do one last graphing problem. And for this last graphing problem, we're again going to graph standard form. The difference is that, as you might notice up here, that we're actually going to be graphing a standard form inequality. All right, so for this first one, this graph here, in order to make this, well, the first thing we have to do is we have to find our x-intercept and our y-intercept. Well, I hope you notice that that's actually going to be really easy. Because does this look familiar? Yeah. The first thing I'd have to do is figure out where the intercepts are. The intercepts are where it's actually going to be equal to 45. So we treat it as an equation when finding the intercepts. And that's the problem that we just did. We just found out on that last set of problems that we did, the last one of them was the equation of this. And so we found intercepts of 5, 0, and 0, negative 4.5. So I'm going to plot those 2 points and then draw a line through them. Will my line be solid or dashed? Solid. Solid, absolutely, because this is a less than or equal to. And so you plot the 2 points, then draw the line. But now we have to look at shading, and the shading is not quite as straightforward with standard form. Nothing is quite as straightforward as it used to be once we hit standard form. Because all of our rules that we had before about less than shades below, greater than shades above, those are all predicated on the idea that we are starting with y by itself on the left-hand side, which is the typical way of dealing with an equation. But when standard form is in there and we have that x over there with it, things have changed. We can't necessarily just use that rule. Now, there is a way that you can make a rule like that. I'm not going to give you a rule, but if you observe one and figure it out, you can use it. But really, I want you to be able to figure out where to shade here by testing a point, which, kind of like finding the intercepts, you'll find is actually pretty fast to do. But we got to kind of talk through this first one to see how. So I'm going to try a point. So I'm going to try plugging some point in for both x and y up here. Something easy, something I can calculate real easy. What would be a nice easy point to plug in there for x and y? You can use any point that you see on the graphing grid to test this, except for the ones that are right on the line. Because if you plug it in right on the line, all it's going to do is tell you they're equal. And we want to know whether a point is either greater than or less than. And you could choose any point out here. You know, I could choose that point at 3, 2. I could choose a point over here. I could choose a point down here. Doesn't matter. But I do want to choose something that's going to be very fast and easy. And my favorite for that is 0, 0. Because if I plug in 0, 0 into my inequality up here, I'll write out the long way first. I didn't even really have to think to figure out what that left side equals, though, do I? Because 9 times 0 is 0. And 10 times 0 is 0. And 0 minus 0 is 0. By choosing 0, 0, it makes that a very fast process. And so I can just say, okay, well then, is 0 less than or equal to 45? Is that a true statement? Is 0 less than 45? Yes, it is. Because that works, that means this point, 0, 0, works. That means I should be shading the point at 0, 0. But if I'm going to be shading 0, 0, can I just shade like one point on that side but then have to shade everything on the other side? No, it doesn't work like that. If one point on that side is supposed to be shaded, that means every point on that side is supposed to be shaded. And so by testing a single point, if it works, shade that side. If it doesn't work, shade the other side. And that's how we know where to shade from standard form. Right, now, having gone through this process of working with standard form, you've seen now it is a bit of a process. There are some steps there that we haven't had to deal with in previous math problems. And so what I want to do before we hit our practice work is give you some notes on it. Give you kind of this outline about exactly what this process is for how to graph from standard form, so that should you forget it later, you can look back at your notes. A great place to put this would be right below where you took the notes earlier today on what standard form is.